In the previous video, we began to think about what happens when you have a spring hanging here and you begin to pull down on the spring. Here's the basic story, right? We think about the spring hanging there all by itself, unstretched, as having a length L. And then when something grabs onto the end of the spring stretches by an amount delta L. Now, when the spring is extended, the spring exerts a force on my hand, and my hand exerts a force on the spring. By Newton's third law of motion, those forces are equally strong. So what we want to do in this video is do an experiment to better understand the relation between the strength of those forces and the stretching of the spring. To start, we're just going to notice where that hook at the end of the spring falls when the spring is just hanging there unstretched. The bottom of that hook is at about 44 centimeters. So now we want to see what happens when something is pulling on the end of the spring. So I'm going to start with this 100-gram mass, and we're going to estimate. We'll say that a 100-gram mass weighs about 1 newtons. So if I hang that 100-gram mass there, we know that this weighs about 1 newtons. So gravity is pulling down on the mass with a 1 Newton force, but the mass is not falling. So we know the spring must be pulling upward on that 1 Newton object with a 1 Newton force. So our spring force in this case is 1 Newton. And we want to see in this case, what is the stretching of the spring? So as before, what we're going to do is just look at where that hook at the end of the spring lands on our centimeter scale, 54.5 centimeters. Okay, so from 44 centimeters to 54.5, that's a stretching of 10.5 centimeters. All right, now let's see how the stretching of the spring changes as the force that it needs to exert changes. So now I'm going to remove this object that weighs about 1 Newton, and I'll replace it with another object that weighs about 2 Newtons. Okay, and this time it falls at about 65 centimeters. So from 44 centimeters at rest to now 65 centimeters, that's a stretching of 21 centimeters. And now let's hang both masses on there. And with both masses hanging on there, we know that the spring has to be exerting a 3 Newton force to support both of those things, about 75.5 centimeters. Okay, so starting from 44 centimeters going to 75.5 centimeters, 31.5 centimeters. So let's look at the pattern here. For a 1 Newton spring force, the stretching is 10.5 centimeters. For a 2 Newton spring force, the stretching is 21 centimeters. And for a 3 Newton spring force, 31.5 centimeters. Now you can see that when the spring force doubled, the stretching doubled from 10.5 to 21. Right? And when the spring force tripled, the stretching tripled from 10.5 to 31.5 centimeters. What we say here is that the spring force is proportional to the stretching of the spring. The way we would express that mathematically is by saying the spring force is proportional to the stretching of the spring. Okay, this is a symbol that simply means proportional to. When you see this symbol, it means that when the quantity on one side doubles, the quantity on the other side doubles. When the quantity on one side triples, the quantity on the other side triples, and so forth. Okay, so in the next video, we're going to take this proportionality and make an equation out of it and talk about what we can do with that.